Hello, in this video we'll be looking into reacting masses and we're going to do some mole calculations. Before we proceed on to doing the actual calculations, it's quite important to understand the meaning of the word molar ratios. Whenever you get a chemical equation, when it's balanced, the numbers in front of them indicate to you the quantity in moles that the different reactants are present in. So the number in front of C3H8 is 1. That means 1 mole of C3H8 combines with 5 mole of oxygen to form 3 mole of carbon dioxide and 4 moles of water. So if I change the number of moles, if I doubled C3H8, so if I made that 2, then that means 2 moles of that would need to react. Everything else would get doubled, you see. So that would be 10 mole. That would be 6 mole. And that would be 8 mole. The same way, this one is 2 moles combines with 1 mole and to form 2 moles of calcium oxide. Now, if I had 1 mole of calcium, how many moles of oxygen are needed to react with it? So what I've done is I've halved it. So I've divided it by 2. So you would also need to divide that by 2. So you get 0.5 mole. And then again, that would go half and you would get 1 mole. So same, this is 2 mole, 3 mole, and 2 moles. So in the calculations that we're going to look today, if I gave you Fe and chlorine, then you would do Fe and chlorine are in the ratio 2:3, and then you would be able to do the rest of the calculation. So when we talk about to use molar ratios, what we mean is to extract that data out. So the numbers 2 and 3 come from the balancing. So let's take a look and I'll explain to you how we're going to be using these molar ratios. So molar ratios come from the balancing. So it's important that you need to balance the equations correctly. And if you need to understand more about balancing and how to write formulae, please look at some of the previous videos that I've posted. Whenever you do calculations, I always teach calculations in a very simple way. Use a structure and you will never get any calculation wrong. So whether in reacting masses, reacting volumes, or even titration, any calculation you do, just follow this structure. So the steps are basically 3, 1, 2, 3. We'll find the moles of known, find the moles of unknown, and we find the answer. But before we do that, we need to be able to do some basic work. So let's take a look at a question and we try to solve it. When you look at this question, you will always be given some data. So you've been given 10 grams of calcium and you have to find something else. That means something is known and something is unknown. So what you do first is you decode the data. So you need to be able to write down the equations. So I've written 2Ca plus O2 forming 2CaO. Now I need to extract the data. So I've got 10 grams of calcium. So I'm going to write calcium mass is 10 grams. I need to find mass of oxygen. So I put question mark underneath oxygen. Now that you've done this much, you need to do the first step, which is always to find the moles of known. So you need to find moles of calcium. Now we know formula, because the data is in gram, so I'll use the formula mass, and because it's an element, I'll find the atomic mass. So the formula is mass over AR, data is 10 gram, atomic mass is 40, so you would get 0.25 mole of calcium. The second step is to find the moles of unknown. Unknown is oxygen. We need to use mole ratio. So you do calcium and oxygen, and as I explained in the previous few minutes ago, you use the balanced equation to figure out the moles. So you write down those numbers and then you say calcium I've just found 0.25. So what is that. So the ratio is 2:1. Whatever is calcium, oxygen is just half of that. So whatever is that, you just see half of that. Therefore, this would be 0.125. And therefore, you come to the last step, find the answer. Answer is equal to, what is the question asking you to find? Question is asking you to find the mass of oxygen. So mass of oxygen is equal to moles times mR, 0.125 times 32. That is equal to 4 grams. So that's the answer for this question. Let's try another one. You could pause the video and give it a go. And if you still haven't followed, let's do it together. So you write down the balanced equation, CuCO3 forming CuO plus CO2. Extract the data, so 7.41 gram of copper carbonate. So we've got that. So what mass of carbon dioxide? Question mark. Do the first step, moles of known. Known is the one that for which the data is given, which is copper carbonate. Moles is equal to mass over mR. So the mass is 7.41. Molecular mass of copper carbonate you would find out. So you'd add the atomic masses of each element, and that would work out as 123.5, and that would come as 0.06 mole. Then you need to find the mole ratio. So you need to use the mole ratio of copper carbonate, the known and the unknown. The unknown here is carbon dioxide. So copper carbonate is, you've been given, look at the number. So the number is 1. So mole ratio is 1:1. So copper carbonate, you've just found 0.06. Because it's the same moles are present. So carbon dioxide, you would say, is 0.06 mole. To find the answer, what is the question asking you? The question is mass of CO2. Mass is always equal to moles times mR. You've just found the moles there. So 0.06 times mR, which is 44. So the answer comes out 2.64 gram. Let's try another one. So you could pause the video now and try it out. So I'll show you the scaffold, show you the structure. You can pause the video now and you can solve the question. And if you've had paused the video and if you've just come back, so let's check if you've got the answer in the right way. So you would have done this first, decoded the data. So you've got MgSO4 and H2. What mass of hydrogen, so I'll put question mark under hydrogen, is formed when 2 grams of magnesium. So I've been given data for magnesium. Now I need to find out the moles of known. Known is the substance for which the data is given. Moles of magnesium is equal to mass over atomic mass. Mass is given as 2. Atomic mass of magnesium is 24. So I get 0.0833 mole. Next is mole ratio. So molar ratio of known and unknown. Known is Mg, unknown is hydrogen. I'll look at the equation. The mole ratio is 1:1. So again, it's the same. So whatever you've got for magnesium, you will have the same number of moles for hydrogen. So we come to the last step, which is find the answer to the question. So the question is asking you to find out the mass of hydrogen. Mass of hydrogen is equal to moles of hydrogen times mR. Moles of hydrogen you've just found is 0.833. Hydrogen molecular mass is 2. So your answer comes as 0.167 gram. So I hope you got this answer correct. If not, then review your mistakes. It's always good to learn from your mistakes. but remember the steps. So in summary, what we've just done is looked into the calculations. You could try this calculation yourself and check out whether you've got the correct answer or not. So give it a go and all the best, and I hope you get the answer. Do post your answer in the comment section and I'll get back to you if you've got the correct answer. So thank you for listening.